Hi everyone, my name is Rishi and today I am going to explain my project which I have done on retail sales prediction which is under supervised machine learning mode. So let's start. Uh, these are my team members which we are done the project with the team, and here I have added the summary of the project, which is we have two data set here. One is for Roseman store and other one is for Roseman, and we are just trying to build a model here which can give the best prediction for the retail sales. I have added my GitHub link here to the easy access. Our we have described the problem statement here, and coming to the basic data points, but what our data set, the with the columns our data set had. So in there we have two data set here. We have ID, store, sales, customers, open indicator like school holiday, store type, assortment, completion distance, promo 2. We will be understanding these all the features once we start begin with the project. So let's start with the coding here. So coming to the very first, which is the library. So I have imported the library which I have used so far during the model. Few of the libraries we will be importing during under the project as well, as per the requirement. So coming the very first, we will be just coming to the data set reading wala part. We have just updated our data set here. We have updated, we have read both the data set using just read CSV. Then we have two data set here. So for the Roseman data set, we have take a keyword named data. Sorry, for Roseman data set, we have take the data set name as sales df, and for store data set, we have taken the variable as store df. So let's have a first look of both of the data set. So we have sales data set here. So we just check the head here, we just check the information here, and also just to view the dataset properties, we have checked few of the description we have checked here. Then let's check what are the value. There are different columns. So for example, let's take a column named state holiday. So we have just check what are the numbers are there in the state holiday. So we have checked that yes, the kind of number are there in the state holiday feature, that is in column. And then we check the date, unique dates, which we have checked the unique date inside the particular sales df data set ki, from where to where these entries are belongs in the I would say duration. Then coming to next, uh, then we have checked this. We have now what we did, we checked the null values here, how many null value we do have. So we can see that in sales data we did not have any null value here. So we have checked it so far, and again we have checked the information. Then what we did, after checking, we will be wrangling the data, wrangling in a kind of manipulation in the data. Is there any null, is there any kind of anything, deletion, addition of the column. So these all the things we would be doing in the data wrangling wala part. Got it. So we have checked that sales holiday, the sales holiday has two kind of value. That is first is one, other one is zero. Then uh, other data set we have df, that is the store data set. So we have checked that yes, these much value are null here in the respected column. So what we did, we check yes, what kind of. Huh. So here, what we check? We just check the three column here, and we check how many what are the unique value under these three columns. So we can say in day of week column we have number of week, like first day, second day, third day. So that kind of data that column having. In state holiday, it's a B, C, and zero. That kind of data. And school holiday, that is zero and one. Then coming to the next, we will check the number of unique. So as we can see, the unique ID are these much unique id, these much unique. So we have checked the all unique data in each column. So we have checked that yes, these much data are unique in the column. So then what we did, we just fill the uh, we just what we did, we just fill the null values. So we can see the completion distance stored here, completion distance we filled up with 0. Similarly, completion distance which month, since year, promo to promo, all we have filled with 0. Then coming to next part, now after replacing the null value, we have checked that yes, all the null values are filled. Then coming again, that we just have a look of our data, we have seen that yes, these much rows and these many columns are there. Then what we did, we just merge both we have two data set. One is for sales data set, second one is for store data set. So just to make a machine learning model, we have to merge both the column, as we know that both the column have the store id as unique column, sorry, as common column. So what we will, what we will do, uh, we will just merge both the we will just merge both the data set on the store basis with the left side. So the final data set we would be having these much rows we would be having, and these many columns we would be having the final data set. Now what we did, we would be just replacing few things here. As we seen that state holiday include 0 a b c, so what we did, we will just replace a b c in by the numbers. So we did key where 0, it should be 0 a, it should be 1 2 and 3 similarly. Then again we just what we did, we find a state holiday is equal to, we also change the data type. So it, as we have seen, it was kind of object earlier, then we have changed it to integer. Then come to the assortment part. The similar thing we have done, key ABC we change into 0 and 1, and same we have changed the type of the data. Why we are doing this? Because when we create the model, so these will be the kind of independent variable. So this should be in the value format, I would say, not in the object form. That's why we are just changing, standardizing the data, I would say. Then come to the, then similarly to type we have standardized. Next, then what we did, we have checked the n unique. Yes, 4 unique value are there, 3 unique value are there, and 4 unique value are there. Then we just check the final info of the final info of the final one data. Then we check the how many value counts are there in sales. So we check yes, these many rows are there which sales is 0. This will make a huge impact when we create the model. So what I will be discussing it key, how we will be dealing with this. So what we did, then again, as we know, we have a date column in the, we have date column in the data. So we have changed the that particular column into date format using PD date time, and yes, uh, PD to date again. Then we have changed this as well. We have changed this. We have changed the completion year as well. We do have different. We have changed completion distance as a in type, because as we know distance is the numeric value, so it should be in integer. Then again, we finally check that yes, these are the all the data set. These are all the columns we have. These are the data type. Now we find that yes, my data set is now good to go. Then let's understand their variable. So first we just check the head value. We have just checked the final head, final dot head with the final dot head. Then what we did, because as we seen key, just we just describe our and round the value till two of the decimal points. So this one we can see the description of the variable. Then so till here what we did, we did kind of data wrangling part. We did data cleaning where we replaced the null value, we changed the data type. These are the kind of things we have done so far. Okay. So coming to the next part of the data. So as we know, the best way to understand the data just to visualize it. So what we did, we are just going to visualize our data with data visualization. Yes, storytelling, a kind of I would say explanation would be there, so that we can understand the data, understand relationship between the data. So coming to the first, I would say visualization. Coming to the first chart, what we have done. So we have checked the uh, kind of relation between sales and competition one open sincere. So what we did key, we just check the competition. So how sales affect when the competition is going to high. So as we can see, yes, initially when the sale in 1900 the sales were this, then it was up and down, up and down, up and down. In 2000, just because the high competition, the sales would be getting decreasing. As we know, this is the kind of basic understanding. Next, we check that yes, promo, how about how the sales is impacted by the promo. If the promo is kind of good, then how it is affected. So in initial, in 2009 it was good, then earlier the day in 2007, when we was doing the promos, it was highest. Then again in 2015 it was kind of medium, as the competition was high. So we can say yes, as we are the sales in 2000 are very low in spite of promotion, the region carry more competition. Exactly. So as we have just doing the promotion, we have checked that yes, sales is getting affected, I would say. Not much increasing, but yes, it is somewhere affected. So next part I'm coming, that day of week versus sales. So what means which day the sales is happening. So as you can see, Monday is the day where maximum sales is happening, and similarly is decreasing till the last day, and the 7 day which is on Sunday. So maximum store used to be closed, so it will be the least sale Sunday. Next, coming to the plot between sales competition, open sales month. So as we have seen, if the competition open since 1 month, so sales was low, and at the competition, as the competition month increasing, the sales would increase. Why? Because when the new store used to be open up, this will affect a current store much. But as the time of the store will increase, so yes, this will not much affect the sales. So that's what the chart is saying. Coming to the next plot here, we have just use box plot as well. Here, the box plot store type versus sales. So we have seen we have four type of store, which store have the maximum sales. So we have visualizes, yes, if the store type one having the maximum sales, as we have seen in the plot, and also outliers are there. So we will be kind of doing that kind of things. Yes, the data distinction should be there. Yes, this is expected, though this is affecting, or I would say this is doing much better in terms of sales. Then we have seen the assortment, what kind of which assortment is doing the good sales. As we see again, one type of assignment is doing the good sales. Then what we did, Deg Singh's open is store daily open count plot. So what we have did here, we just plot what 2 days. So day of week, and uh, the sales. So we can say that because on a Monday the sales would be high. Close. This is the thing which mean ki number of number, sorry, one is number of open store, zero is number of, as we can see, ki on Monday it is the most maximum store open, and similarly till Sunday maximum store would be closed, and least store would be open. Okay. Next, we check the how holidays are affecting our sales. So we check, yes, state holiday. If state holiday is not there, sales is high, and when state holidays are there, sales is kind of decreasing. Yes, as we know, if the holidays is there, definitely store would be closed, so sales will be affected. Again, for the but this is for state holiday. Now, if it's school holiday, sales is not that much affected, just because a school holiday would not affect the stores, because definitely will not. If there is a school holiday, store will not be closed, so it will not affect much. So in that visualization, we have kind of conclude the things that yes, from plot sales, we have seen that yes, he since 1 month, so sales go increase from the November and highest month December. From plot sales, and day of week says highest on Monday and start again. Same we have discussed. Again, played with ensure that the promotion helping increase sales. Yes, type of store important pattern store fees. So we have conclude our EDI. I would say the visualization in these particular 8 points, which will be help to understand the data, help to understand about the data. So this is all about the kind of, I would say, data visualization and explaining about the data related. Okay, coming to next part, the very important part, which is feature engineering and data pre-processing. So, what is feature engineering? In feature engineering, we would be checking about in the data that what kind of features are there and how, if there is a requirement to kindly manipulate the feature which we known as column as well. So, what we did, so we check first the correlation between the data. So, I have checked the correlation in our final data, and we have the correlation chart, and we observed few things here. Here's how data is correlated which each other. Here we have seen, yeah, that few of the column are, we have checked, yes, these two columns are correlated, highly correlated with each other. So this will lead to a multi-collinearity. So in the next step, what we have checked the multi-collinearity between the columns. So as we know, the variance inflation factor, which is VIF factor, we have in the Python here. So which will help us to check the multi-collinearity between the data. It means the relation between the columns is high. It means we would not require one of the column between those two or three. So what we have done, we have imported the dictionary here. Sorry, we have imported the libraries here from stat modules dot stats dot outlier influence. We have imported VIF factor. Then we created a function where it will help to return the VIF for each column in the data set. This is the common function we have created. Then we pass our data set, we pass only independent variable. We have removed the our target variable, and we have passed all the independent variable which is has the only numeric value. We just describe it and pass those particular column, because we affect the because the relation will, we can check only for those factors which has numeric value. I mean, we cannot check the relation between a categorical value, as we know. So we what we did, we just passed the numeric column to the VIF factor, and we have checked the VIF value of the each column, excluding sales. And out of 18 columns, the VI factor written 14 column. I think the rest three column would be kind of category value. So what we did, so here, so we can check here in the VIF table. We can check the all the values are okay, 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 okay. And here we check that yes, these column and this column having the higher VIF value. So we can say that it is more than, and the general rule of the VIF factor is, if the VIF value of a column is less than 10, then it is good to go, else we have to kind of manipulate those particular columns. So as we can see that promo 2 and promo 2 sincere are highly correlated. So we have to drop one of the columns. So what we did, we have dropped the promo 2 column, and again pass all the things in that particular vi function, and again check the vi value. Now we can check that yes, promote sincere had the good vi value. So vi factor below 10 is look good. So machine learning model, so we have just created the vi value, vi factor. So this will help us to make a more effective model during the ML process. Okay, now we have check our targeted variable as well. As we know ki our targeted variable, a few of the rows are they are having zero sales value. So we have taken those rules. We have taken that yes, more than 1.7 lakh rows are there which had zero sales value. So what we have did, we just break our model into two parts. What we did, first we will do we will create a model without having rows uh, with zero cells, and second we will create a model having rows with zero cells. So what we did, I have dropped all the rows and created a new data, that is new df, and check yes, now this is the new data that rows got excluded. All right, we have just seen, we again kind of so for promo interval, as we know, promo interval, we will check here that promo interval having a categorical value. So we have created the dummy value, dummy for dummy value dude, dummy value will change your categorical value into the numerical value. So it will standardize your data. So this code will help us to create the dummy value. So now we have now new to CL, and what we did, we have we again take this clean data, we export this clean data and take as a clean data, so that if we require in future we can get that clean data after model training. Now, coming the main part of the project, which is model training. So, so with the very first, we would be requiring a few more libraries. So, I have imported all the libraries here. So, few of the libraries may be included during the code as well. So, as we have discussed earlier, yes, we would be creating two model here. One would be excluding rows which has sales equal to 0, and one will include row which has sales equal to 0. So first we will be creating a model excluding those rows. So as we know, those kind of rows having the data set which is new data, so new data. So what we did for the model training, uh, we just create the dependent and independent variables separate. So as we know, our dependent variable are is sales, and rest are the independent variable. We did not take three variable, which is promo sales, year to year, date, and sales, as we have checked that these two column is not required, it not will much effect in the model, so we have excluded those as well. So now we have independent list of independent variable here. What we did, so we just passed the value of independent variable with x, and the value of independent variable with y. Then we do sim train text split with the 20% kind of data. We have these kind of things. Then first we train the model with regression, which is what we did, linear regression dot fit extend by train. So the regression score come to 70.76, means 76% is accuracy of the model. Okay, then we check the coefficient. These are the coefficient of each particular column. We required to check the coefficient as well, which column is more effective to the, I would say, prediction. Then we check the intercept, the value of b mx plus c, the value of c, I would say. If it means if all these kind of columns are zero, then this would be the kind of prediction would be there. Then what we did, we check a prediction. What we did, if I predict equal to reg dot predict extend, we check yes, this kind of prediction are there, and y test are there. So the we can also this is the actual value, this is the predict value, so we can check the difference. Yes, the accuracy we can measure there, that 76% accuracy, and we can check the difference. And again we check the difference with trend as well. So this is the trend prediction, and this is the trend actual. So we can check the difference between prediction versus actual. Okay, coming, as we know, in the regression model we would require two three things. One is for mse, we will print the same. One is rmse, we will print the same. And r2 value. So we have checked that our linear regression accuracy is 76%. Got it. We also kind of dip those thinking what is the actual versus prediction. We have just made the rule, and we can have the difference here, this kind of difference is there. Then we have lasso and ridge. So after linear regression we have included we have done a lasso and ridge model here. So with lasso we just a similar thing, we import the library, we pass the things with the alpha value of 4, iteration we have taken 10,000, and selection we have taken the cycle. And tall is the tall value, which is kind of we required, so we have taken the 001. We just call the function extend y train, then we have taken the kind of prediction value. These are the L1, this is the L1 score. For Lasso, we would require to check the L1 score, and as we will check the CV score. CV score mean the L1 score for each particular column. Then we have checked the mean CV score. So mean CV score mean कि mean CV score mean कि which the medium CV score. So as we can see, there is a kind of 75. So this will refer that in Lasso model, the prediction would be accurate up to 75%. So it is, I would say, it is lesser than linear regression. So in this case, linear regression is better performing than Lasso. Then again we come to the grid search CV. We check grid search CV. What we did in grid search CV, we can check the same model, the different parameters. So we have checked the alpha value and the 5 value. Then we have checked the with the L1 with the Lasso. We have passed the parameters, and what we check, the best alpha value is 0.2. As we know, we have initially taken the alpha value as zero point 0.4, so the model was predicted as 75%. But as we use grid search CV, so and we have seen that in at alpha value of zero point 0.2, the model is predicting 76%. So yes, here we can get that if we keep the alpha value zero point 0.2, so the model will be somewhere best performing. So this will help. Then again we have taken the actual endpoint. Then we just go with ridge, and we know in ridge regression we only require the alpha value. So we have taken initially as 5, and we just predicted the model, and the L2 score is similar to nearby to L1 score. We have imported the things. Then again we do the similar thing, ridge equal to max. We just doing the again grid set CV for the ridge regression, and iteration we have taken 1000. And again we have taken the all the 5 value and pass the uh, grid search. Best alpha value we have taken from the best param, and best score we have taken from the best score. And ridge best equal to ridge best alpha max station, where we have get the where we will get the best ridge value. So in that case, what we have, best alpha value should be 5, best score is 76, and minimum CV score is this, and sorry, maximum CV score is this, and corresponding alpha value is. So we have seen that yes, 77% we can go at the point 5. So this way we have a kind of inclined Lasso and ridge regression. And we have checked in Lasso. I think we get the value approximately 76, and yes, in alpha we got the value approximately to somewhere 77. Okay, then come to the elastic net. As we know, elastic net is the mix of ridge and lasso. So we have again do the trend test split. We have elastic net here. We taken the parameter for both alpha. Alpha used to be for ridge regression, L1 is used for lasso regression. We have passed the same in grid search CV, which is elective parameters, and CV we have taken 5. Elastic neck dot fit we have done, and the best value we have taken from here, and we have checked the best alpha value is 1, the best alpha ratio value is no is 0.9, the best score is 70.76, and the same is for test score. So in ElasticNet we have uh, achieved that particular 77. It is similar to I think Lasso and Ridge. Again we have decision tree here, so we just check the decision tree. We take the mean of the sales, just we will be using later. We have taken new dependent variable of the mean, which is the uh, mean of the dependent variable. So in decision tree regression, we have depth of 5. As we know, depth is the how many depth till we should go. Then we fit the model, we wipe decision tree, and wipe train decision tree. We check the MSE. So in decision tree, MSE is this, and RMSE is somewhere 1416, and we to check the RB score, which is higher than our kind of linear regression model here. Okay, so this we have checked in four model here. One is decision tree, list, lasso, ridge, and linear regression for the data having not having the rows which is sales equal to 0. Okay, so in the second phase, as we discussed, see, in the first phase we have taken the value which is excluding sales equal to zero values, but now we have creating this, and here we have seen that the maximum accuracy comes up to 79%. So yes, we have keep that, and again we will be creating the same model, but this time we will be taking the whole data set which is final one. So what we did, we just get the dummies for the promoter as we did earlier, and we again taken the same sales dependent variable and independent variable. This time we have also dropped store because that is also not that effective, so we have dropped that as well. Again, now rather than we have taken xy earlier, so now we have taken uv as a variable. So final v values are there, final dependent value are there. We have taken u and v. We have a final one of dependent variable. We have taken the data set on which we will be creating our model. So we have done trend test split, the 20% of data. So this kind of data we would be getting. Again, we start with the linear. So in this, with the whole, when we are taking the whole data set, we would be creating only four models. One is for linear regression, second is for decision tree, then random forest, and Adaboost and Xgboost. We would be not choosing a kind of Ledge and Lasso just because we have checked that in the last model the Ledge and the Lasso is similar to regression model, so we would be not introducing those two model here. Okay, so as just for the linear regression, so first what we have done, we have standardized our data first. uh, we have standard our data with the standard scalar utrain and utest. We have so for utrain we have fit the transport, and utest we did not fit just because train data should be trained in the model, so that's why we use fit, and test data should not be trained in the model, that's why we did not use fit. And this way the whole data would be standardized in the same kind of parameters, I would say. Then again we introduce linear regression. We just do the trend test fit. Then we check the v-pred linear. This kind of value we did. Regression score we have checked, and yes, now it is coming 86%. So this is improving somewhere. Again, we have done the same thing. Actual pred we have, okay, and then we have okay, so we have checked our MSE score just for the linear regression model. So we have checked the MSE, RMSE, and RMPS. That's the percentile RMSE, I would say, and this is the RT score. That so that we have just checked. Yes, we are achieving a good kind of model here with the 86% of accuracy with the linear regression when we are taking the whole data set. Now, coming to the next model, which is decision tree. So the same thing we would be doing here. We are just training our data with the depth of 5. We train the data, we check the biped and extred, and we just get the MSE, RMSE, and R score. So again, we have just checked, yes, we again improved. Like here, we achieved 8684. Here we achieved 8687. So again, with the decision tree model, it is getting improved. So we have just print the actual and prediction value here. Then we, as we know, random forest is there. So for the whole data set model, we have taken the random forest. So in random forest, what we did, we just fit the model with the depth of 5. So random forest is the same kind of decision tree model, but it is as we know, we can just check the details of random forest. So as we know, ki random forest is also kind of a model similar to decision tree, which will take the decision using that depth by the terminology, I would say. So in random forest, we have just taken the 500 estimator, depth is 4, and range of is 2. That's the format of the, I would say, parameter for that particular random forest. We just fit the model, we check the vibrate, we check the MSE. uh, for MSE, we have checked the same. We would be checking MSE, RMSE, RMPSE, and ASCO for each model. So here we have checked we have achieved 92%. So when we switch to decision tree to random forest, it is improving exponentially. Like from 86 to 92, we are going good to. So we have checked it. Yes, with this model, we are achieving a kind of accuracy with 92%. Then, as you know, we have Adaboost as well. So Adaboost is also kind of similar model, which estimator we have taken and the learning link with 0%. We have just fit the model and we put the Adaboost predictive test. We check the MSC, and here we have checked the yes. Adaboost is just similar to I would say linear decision tree. It is not kind of matching the accuracy of random forest. But yes, as we know, we introduce it, so we are just keeping it. And the last function is Xgboost. Xgboost, the a revised version, or I would say extreme version of Adaboost. So, so again, we have taken the same thing. It also works like random forest. We have taken the XGBoost regression, XGBoost fit, we distributed, and again the. So here we can check. We have achieved a 98% of the accuracy with the Xgboost model. So we have applied four model with the whole data set. One is for regression, that is linear regression, again decision tree. uh, Third one is kind of random forest, then Adaboost and XU. So this way we have implemented our model and we have achieved that kind of accuracy, which is 90%, which is good enough to I would say good to go model, we can say. So this way what we have achieved here. So in the summary we can say that when we have taken the model, the data without uh, excluding the rows with zero, it is just giving the accuracy of 79 to 80%. But when we take the whole data set, it is giving the kind of accuracy of 92 and 98%. So yes, in this way we can summarize ki yes, just to get a good model, we will be taking the whole data set, that is including the sales equal to zero values. So we have taken all the rows and we achieved the model accuracy is 92%. So in the conclusion, again, we have just checked the same, we have just wrote the same case. Uh, we saw that this we created the data frame, removed zero, and we achieved the accuracy of 74 and yes, 79%. But where, when we include the real, we achieve the accuracy 90%. So we can conclude that removing say equal, we have to remove a lot of information from the data. It is quite large, and there is decided not to. So in the final, yes, we will go with the model where we will taking the whole data set as our data set, because those rows which has sales equal to is getting a lot of information. Yes, although it is sales equal to zero, but rest information are there. So we will be including that model, and we got our best RMS score with random forest and gradient boosting technique like Adaboost and Xgboost. So we tried talking in Aptom parameters, so our model doesn't outfit. We also check yes, model should not be outfit, but it should not be 100% as well. Yes, we have taken 92 or 98%. This is a good to go model. So this way we have created a model which will help us to predict the retail sales here with the kind of supervised learning model, and we have achieved a good accuracy. We have divided our data into two parts, and we just experimented on our data. So in this way we have achieved two different model. So first model is not much better, just because we get the accuracy of 75% or 74%, and the second model with the whole data set, we have achieved the accuracy of 98%. So yes, we can say that yes, for this kind of data we should take a whole data here, and using that particular data we can go with the model, and yes, we can achieve a good accuracy here. And yes, if I talk about which for this project which model is good, so yes, random forest, because it's giving you a kind of 92% accuracy, and Xgboost and Adaboost is also a similar accuracy kind of, like Adaboost is given low but Xgboost is given 98%. So yes, random forest and Xgboost are the best model for this project. So this way I'm just wrapping up this project, and thank you so much. I'm just wrapping for this. Thank you so much.